For thousands of years, humanity has looked toward the sun with a mixture of wonder and fear. Every civilization has tried to explain its incredible power. Some believed it was a god, others thought it was an endless ball of fire. Even after centuries of scientific discoveries, one question has continued to challenge researchers around the world. What is actually happening inside the sun? At first, the answer may seem simple. The sun is a giant star made mostly of hydrogen and helium, but that explanation barely scratches the surface. The closer scientists looked, the more mysteries they found. Some of the sun's behavior appeared to break the very rules of physics that govern everything else in the universe. The greatest challenge wasn't just understanding the sun, it was reaching it. Imagine trying to fly a spacecraft into an environment where temperatures can reach millions of degrees, where streams of charged particles race through space at incredible speeds, and where intense radiation can destroy electronics in moments. For decades, many experts believed getting close enough to study the sun directly was simply impossible. Yet human curiosity has always pushed beyond impossible. Engineers designed a spacecraft unlike anything ever built. Every component had one purpose: survive where no spacecraft had survived before. It would have to travel faster than any human-made object in history, endure unimaginable heat, and continue collecting data while flying through one of the most hostile environments in the solar system. After years of planning, countless simulations, and groundbreaking engineering, the spacecraft began its historic journey. Instead of flying straight toward the sun, it followed a carefully calculated path around the inner solar system. With each pass, gravity gradually pulled it into a tighter orbit, allowing it to move closer and closer to our star. Each approach shattered previous records. As the spacecraft accelerated, its speed climbed to nearly 430,000 miles per hour. At that velocity, even tiny particles of dust carried enormous energy, making every moment of the mission incredibly dangerous. Then came the most dramatic phase. The spacecraft crossed into the sun's outer atmosphere, a region known as the corona. This wasn't simply flying near the sun, it was actually entering part of the sun itself. For a brief period, communication with Earth stopped. Mission controllers could do nothing except wait. Had the spacecraft survived, or had years of work ended in silence? Minutes felt like hours. Every scientist in the control room knew there was no way to intervene. The spacecraft was completely on its own, protected only by its advanced engineering and the hope that every calculation had been correct. Then, a signal arrived, weak at first, then stronger. The spacecraft was alive. Not only had it survived its close encounter with the sun, but it had also recorded an enormous amount of scientific data. This data would reshape our understanding of how our star truly works. One of the biggest surprises involved the sun's atmosphere itself. Most people assume that the closer you get to a heat source, the hotter it becomes. That's true for a campfire, an oven, or a light bulb. But the sun behaves differently. Its visible surface has a temperature of about 10,000 degrees Fahrenheit, or around 5,500 degrees Celsius. Yet the corona, the thin outer atmosphere, can become hundreds of times hotter, reaching temperatures measured in the millions of degrees. That makes almost no sense. How can an outer layer be dramatically hotter than the surface beneath it? For decades, this question became one of astronomy's greatest unsolved mysteries. Scientists proposed many theories. Perhaps powerful magnetic fields were twisting and snapping, releasing enormous amounts of energy. Maybe tiny magnetic explosions were occurring every second. Others suggested that invisible waves traveling through the sun's magnetic field were transferring energy outward before releasing it high above the surface. But until someone could actually measure conditions inside the corona, these ideas remained educated guesses. The spacecraft finally provided that opportunity. As it traveled through this hostile region, it detected rapidly changing magnetic fields, unlike anything scientists had observed before. Instead of smooth flows, the spacecraft found an environment filled with violent bursts, sudden reversals, and constantly shifting streams of charged particles. The corona wasn't calm, it was alive. Powerful magnetic forces were bending, twisting, and reconnecting with astonishing speed. Every second, invisible energy was being released across enormous distances, heating the surrounding plasma far beyond what anyone had expected. The mission also revealed that the solar wind is far more chaotic near its source than previous computer models had predicted. Rather than flowing smoothly, it begins as a tangled mixture of high-speed jets, magnetic turbulence, and rapidly changing plasma structures. Understanding this matters far more than most people realize. The sun doesn't simply provide warmth and daylight, its activity affects nearly every piece of modern technology. Powerful solar storms can interfere with GPS navigation and radio communications. They can damage satellites, expose astronauts to radiation, and even overload electrical grids on Earth. As our dependence on technology grows, predicting space weather is becoming as important as forecasting hurricanes or severe thunderstorms. Every new measurement collected brings scientists one step closer to understanding when dangerous solar events may occur. For the first time in history, humanity wasn't merely observing the sun from a safe distance. We were exploring its atmosphere directly, and what we discovered suggested that the biggest mysteries were only beginning to unfold. Because hidden beneath the blazing light lies an engine unlike anything else in the universe. An engine capable of shaping planets, influencing climates, and controlling the very conditions that make life on Earth possible. As scientists continue analyzing the data returned by this journey, one thing has become clear. The closer we get to the sun, the more astonishing it becomes.